Our next unit, and the final one concerning relational database design, is normalization, which is something we've actually already been doing with our tables. Normalization is concerned with breaking up our data into tables to stop it from being redundantly stored more than once in the database. The two main issues with redundancy are that it needlessly wastes disk space and that it increases the potential for data corruption, any kind of problems that could occur when modifying the data in one place but not in another. To help us normalize our database and avoid such redundancies, guidelines known as the normal forms have been developed and are used in the industry. In practice, though, you only really see the first three, which we will mention here. To abide by the first three normal forms, we must follow the following rules. 1. Extract similar columns from the same table into separate tables. 2. Extract data that can be found in more than one row of the table into a separate table. And 3. Extract columns that are not fully dependent upon the table's primary key into a separate table. Let's take as an example a modified version of our cities table, which is made to include the country information as well. This example violates the normal forms by storing the currency data in the cities table, while it only depends on the country and not on the primary key of this table. This creates needless duplication. We expect all cities in the UK to have pound as their currency, so storing the currency is redundant, and it might lead to bugs if the UK ever changes its currency, and due to a software failure, we change the currency in only some of the rows but not in others. By splitting the country data into a separate table, just as we had done in our original logical design, we follow the rules of normal forms and remove the duplication. When structured in this way, there's nothing that could happen that would cause a change in the currency for just some of the cities, because all cities point to the same single currency field. Normalization is great for preventing corruption, but because data is spread across multiple tables, retrieving the data using join operations will necessarily be slower than having all of our data in a single table. In some cases, due to performance considerations, you might want to break the normalization rules on purpose and denormalize your tables or choose to go with a document-oriented database, where data is inherently denormalized. As we mentioned, in most cases, when doing relational database design, you would want to follow at least these three normal forms, but the general advice is that normal forms are only guidelines, and if there's any business case for it, the rules could and should be broken.